Hello. So over this next part, I want to discuss some definitions. We've been doing this each week, and we'll continue to keep dealing with different words that are popping up a lot. There's far more than we can cover in MAT101, but we'll take on a couple more. There's been a lot of discussion about the unemployment rate, and we could spend a lot of time on just that one measure and why the current unemployment rate is not reflective of the current situation. But I thought I would shed a little bit of light on that. So first of all, there are a couple definitions you need before you can define the unemployment rate. And this is the thing with any quantitative measure, is whenever you measure something, you have to define what it is that you're measuring. And whenever you do that, you have to leave something out. Whenever you create a precise definition, you leave something out. And a lot of times, with words like unemployment, we have a way that we use that word in everyday language, meaning I don't have a job. But the way the Bureau of Labor Statistics treats unemployment is a little bit more different. They start off first with the idea of a civilian, non-institutional population. So these are people over 16 that are not on active duty, they're not in institutions, jails, and out of that population, we have the concept of a labor force. And the labor force, this is a subset of the civilian, non-institutionalized population. And these are people who are either employed or unemployed, but looking for work. This is important. If you don't have a job and you're not looking for work, you are not considered unemployed. So if you're a stay-at-home parent, a full-time student, if you're retired, those are not unemployed folks. Those are folks who simply aren't working. The labor force participation rate is the chunk of that civilian non-institutional population that is part of the labor force. And it's nowhere near 100%, never has been, never will be. You can go to the St. Louis Fred to look up numbers. I'll show you a graph in a minute. So this rate is the size of the labor force divided by the civilian non-institutional population times 100. And finally, or almost finally, unemployed. So unemployed are people who are not employed during the survey week. The way the Bureau of Labor Statistics gets their data is they have a big pool of numbers, and they rotate through those phone numbers, calling people to ask them about their current situation. It's a polling technique just like presidential approval. You call a sample, and then you end up with a number with a given confidence interval around that number. So there are these various bits that are used to determine whether somebody is unemployed. And if it seems kind of complicated and it might exclude certain people, yeah, you are correct. So finally, the unemployment rate is the number of unemployed people as a percentage of the labor force. So here's just a graphic to summarize that. We have a population in the United States, and that includes everybody: infants, retirees, active service members, people who are institutionalized for mental illness because they've been convicted of a crime or what have you. And then we have the eligible population, folks who could be part of the labor force. And then we have the labor force. And then of the labor force, we have unemployed. So if you hear something like a 7% unemployment rate, that does not mean that 7% of Americans are unemployed. It means 7% of the labor force is unemployed. That's what that says right there. And here's an interesting graphic. So this is from the St. Louis Fred. It's a great resource. So the labor force, who's in the labor force? Well, that's changed over time. So the green line here on top is the labor force participation rate over time. meaning that a smaller percentage of our population is currently working than used to be. So back in the 50s, we had maybe around 85% of the population was working, who were eligible, and then now we're down to say 70%. Looking at labor force participation rate for men, 60% in the 50s, went up a bit, and now it's maybe I don't know, 64, 65% of men in the labor force are actually participating. So these are folks that could participate. And then, of course, women have increased the labor force participation rate a great deal. This is during civil rights, during what's sometimes known as second wave feminism, where women gained access to education and employment, a wider range of employments. So we see that, and this is an aggregate, this is averaging over all women, from low 30s up to now just under 60%, maybe like 56%, 57%. So this who is in your labor force changes over time, and what percentage your labor force, what percentage of the labor force is participating changes over time. All right, so moving on from the economy, maybe going back and just saying a couple of things about this unemployment rate. So again, if somebody's not looking for work, they're not considered unemployed. They would not be part of the labor force. So if you were in the labor force and you were unemployed and you stopped looking for work, you would be part of the eligible population, but not the labor force. If you were in the labor force and you were working, but you retired, you would leave the labor force. You would no longer be counted towards the unemployment rate. So those are two things that can shift the unemployment rate in a weird way. You wouldn't think that people who stop looking for work should change the unemployment rate, but it does. You may not think that folks who are retiring should have an effect on the unemployment rate, but they do. And there are some other measures that are used sometimes, but the number that we hear about on the news can be affected by people who give up looking for work, or from a large bumper crop of retirees from an aging population. Back to diseases. So R0 is a number that's being written a lot about right now, the basic reproduction number. And this is going to come up this week and also at least one more time next week. So what is this thing? So for one, it's pronounced R0, not referring to the zero. And it's the number of cases on average that an affected person will cause during their infectious period. And in particular, the zero is there to represent initially, so at the beginning of an outbreak. This can change, and so sometimes there's an effective reproduction number, or just reproduction number, which is what happens later on after various countermeasures or whatnot are put into place to slow the spread of the condition. R0 is it's not a biological property of the disease. It's not something you can derive from the genome. It's based on a lot of things concerning the population that's exposed and how frequently they interact and all these sorts of things. So R0 can take on lots of different values. You'll see there's an article in the Top Hat assignment where you're asked to kind of look over the article. It's not very long. And there's a table in that article. So things like measles, which are extremely contagious, an R0 of 12 to 18 indicates that a single person could infect as many as 12 to 18 people, whereas influenza, say between 1 and 2, for example. Now, it's of obvious interest for coronavirus causing COVID-19 to know what the R0 is. And we'll talk about why this is, but basically R0, the numerical value of R0, gives us an indication as to whether or not we would expect an outbreak, an epidemic. So knowing very early on, but it's difficult very early on because you don't have a lot of data. And again, it's not something that you can simply figure out by looking under a microscope. It's something you have to measure from actual people becoming infected. So this is a quote from a study. Now it's well, it's not a couple months ago, I guess, a month and a half ago. And some of this language should be kind of familiar to you. So the median with 95% confidence interval, that's what CI means, of R naught of COVID-19 was about 2.28. So meaning that, in 95% of these scenarios, you would expect this to be the median. Because what we're doing is sampling. In this case, they were looking at the outbreak on the Diamond Princess cruise ship. And so that's a sample from society. It's not a perfect sample, but the hope is that if you were to take another sample of that size from anywhere in the world, that you would 95 times out of 100 end up with the same median R naught value. And there's a range, 206 to 252. So there's some ambiguity. The future daily incidence and probable outbreak size is largely dependent on the change of R naught. Unless strict infection management and control are taken, our findings indicate the potential to cause a greater outbreak on the ship. Right? Prescient words. So you can imagine being a researcher and running the numbers and ending up with this. And this is catchy. This is much more catchy than the flu, for example. So this is concerning. All right. Another couple bits of vocab: case fatality rate and infection fatality rate. So I've learned that after discussing mortality rates in our videos, case fatality rate is just taking the deaths divided by total confirmed cases. That's case fatality rates. So let's look at an example here. So, oops, did I skip? What do I do with my slides here? I think my slides are out of order. I'll have to change that. So case fatality rate, deaths over total confirmed cases, and infection fatality rate is the percentage of people who become infected, including those who have no symptoms or mild symptoms, who eventually die. So, how do I have 0.66%? Let me pause here. I need to edit my slides for a minute. All right, I'm back. Sorry about that. So infection fatality rate, this is the number that we're never going to know. If we had perfect knowledge, we would know how many people die as a result of the disease and how many people ever had the disease. But we don't test everybody, and not all deaths are measured. So let's look at an example. Actually, this is still out of order. I just realized. Sorry, let me put this down here. I think this will, yeah, maybe like this. Let's see. We'll figure this out. So there's some trouble estimating the case fatality rate I've been reading about. And you notice through all these slides, I've started linking sources of pretty good articles that I've found, reliable articles. So limiting testing. We've chatted about this before. There's an interesting perspective I read, which is because of limited testing, we're only testing really severe presentations of the condition. If you're not showing symptoms, you're not going in at all. If you have mild symptoms, you may just figure you have the flu. But they're really restricting those tests to only those folks who have a severe presentation. It's reasonable to suspect that the conditional probability of death given a severe presentation is greater than a more mild presentation. And so it might be that we're predominantly testing folks who are more likely to suffer complications, which would skew our rate higher. Also, another tidbit I didn't know is that deaths are something that need to be counted at a hospital. So um, when you're looking online, you're looking at the total number of deaths. These are counted at hospitals. So deaths that are occurring in other places, deaths that are occurring at home may not be counted. So that affects the numerator. And then new research coming out in reports from the CDC indicate that really at a minimum, actually, about 20% of COVID-19 cases are asymptomatic. And it could even be higher. I've seen ranges 20 to 50% of cases could be asymptomatic. And this is why we're being recommended to wear facial masks. It's not for our protection. If I'm healthy, wearing a cloth mask is not to protect me from coronavirus. It's to protect other people because I could be asymptomatic, or my symptoms could be so mild that I don't notice them. A mild fever, a light cough. I mean, it's a cold, wet spring. Um, if you think about it, these these symptoms are symptoms that most of us have, generally speaking. And so wearing the mask is to keep an asymptomatic person from breathing or sneezing on other folks or shelves or doors or whatever. This is pretty concerning. These asymptomatic folks could be spreading the condition and not even realizing it. They feel perfectly fine. So how does this affect case fatality rate? So here, let's do an example. So imagine that there's 100 people who have been affected with coronavirus and have COVID-19. 10 of them have it so severely that they go into the hospital where they test positive for COVID-19. The other 90 are not tested at all. One of the hospital patients then dies from the virus. The other 99 people survive. The case fatality rate then would be 1 in 10. You've tested 10 people, one of them died, that's 10%. But the infection fatality rate would be 1 in 100, or 1%. There was a great BBC article on this. They were comparing case fatality rates in Germany and Italy. Germany has had widespread testing. They have plenty of cases, and their case fatality rate is much, much lower than Italy's, which is like 10 or 12%. So trying to figure out why is it that these things differ by an order of magnitude. Testing. All right, so now on to the asymptomatics. So example, suppose there are 100 infected people and 20 of them are asymptomatic, and out of 100 there are 2 deaths. So then the case fatality rate is 2 out of 80 if you're only testing folks to have symptoms, which would give you 2.5% for case fatality rate, but it's actually 2 out of 100 is 2%. So there's another example of, again, how testing is affecting these numbers. We have a lot of faith in numbers, but there's a lot going on to establish them. If we're testing nearly everybody, there were a couple of cities in Italy that just that have done very well with the outbreak. There was one small city, like Vo or something, and it had 3,000 people, and they just tested every single person. And they've managed to keep everything under control. And so it's been really, really interesting learning the effect of testing. Every number we see is the result of a test or an inquiry or an observation. They don't exist in a vacuum. They're the result of policy, which is the result of human choices and values. The numbers that we're seeing, the differences between them, are the result of values, politics, policies. And then they affect policies and politics. All right, let's pause here and get some practice.